Hi everyone, this is a revision lecture for end term exam. Here I will be covering from week 10 to 12. Uh, Starting off with week 10, I'd like to discuss about the application of discrete random variable DRV. So, uh, it has one unique application that whatever numerical quantity we obtain, like for example x is a random variable for the possible outcomes of 1 2 3 4 5, and a number of uh, variable, or you can say count, number of count is for 50. Okay, so whatever numerical data we get from a count of 50, we can say that it will be very close for x from a numerical data of 500 or even 1000. And what we can find is that greater our count, like x has a count of like 1000, more accurate will be a uh, numerical quantity. So accuracy will be inversely directly proportional to the count of experiment. So here it's not like um, we cannot find uh, approximate value for even 50. It is possible, but I am just telling you about the accuracy. So let's just dive into question part. First of all, I'll be discussing about PMF. So mm, let me tell you guys that for any random variable, suppose here's a any random variable RV, we can generate a CDF. CDF is cumulative distributive frequency. But if uh, a random variable is defined like discrete, so for a discrete random variable DRV, we can define a PMF of it. On other hand, if a random variable is continuous, so for continuous random variable we can define a PDF. PDF means probability density function. So uh, let's start up with the question. So here's PMF is defined for discrete random variable. P of x for a random variable x, uh, uh, x probability takes the value 0.1 for a random variable 0.2, 0.2 probability for a random variable of 0.4, 0.3 probability for a random variable of 0.7, 0.3 for a random variable 0.9, and 0.1 for random variable 1, and 0 for all other values, like otherwise, yeah, otherwise it's 0. Great. So we have to find probability that random variable belongs within the range 0.35 to 0.75. So we can see that for a random variable belonging to the range 0.35 to 0.75, random variable can only take the value 0.4 and 0.7. So we can write it like this. This value will be equal to P of x 0.4 plus P of x 0.7, and this will be equal to 0.2 plus 0.3, and our answer would be 0.5. But here this is the answer. Now you can see that this is a pretty easy question, and you can solve it like verbally also. But now I'll be giving you a question on a conditional probability on the PMF. So we have to find P of x equals to 0.4 given that x is less than 0.8. Pause this video and try to solve this on yourself. I'll explain it in 5 seconds. So let me explain you the answer here. We know that P of A by B is equal to P of A intersection B upon P of B. Pretty simple. So here P of A intersection B, uh, B is 0. Like x for a random variable less than 0.8. So what are the random variables less than 0.8? 0.7, 0.4, 0.2. These three. So here intersection of a set of like 0.2, 0.4 and 0.7 with 0.4, we will obviously get 0.4. So answer would be like this: P of x 0.4. This is the intersection between this set and this set, okay, and below would be probability of getting 0.8, which would be P of x 0.2 plus P of x 0.4 plus P of x 0.7. So we will just use the values 0.2 upon 0.1 plus 0.2 plus 0.3, sorry, plus, can't I just move this? Wait a minute. Yeah, it is 0.2 upon 0.1 plus 0.2 plus 0.3, which will be 1 by 3. So it's an answer. I hope you understand this question. If you have any doubts regarding this, please contact me through comments. Now our next question, this is pretty interesting question. So let a discrete random variable drv with a range 1, 2, 3, like up to some number. So here's the PMF. PMF is P of x with the random variable k, discrete random variable, will be equal to 2 by 3 raised to power k. For k will be this set, okay. So first of all we will see if this PMF is valid or not. We can observe that this PMF is a geometric PMF. So for geometric PMF, we can say that probabilities are positive for all values, as it will always remain positive for k equals to 1 to k equals to even infinity. It will just be same. So we just have to check if all the probabilities sum up to 1 or not. So for summation, we will write it like this. Let me just change the pen. So it would be infinity k equals to 1. Here p of kx will be equal to infinity k equals to 1 2 by 3k. Now I hope you all know about GP, geometric progression. In GP, let me give you a brief introduction. Sorry. Suppose there's any term a and you multiply uh, a number r consecutively for each term. Like first term is a, second term would be a into r, third term would be a into r square, and if you are doing it for n terms, it would be a raised to power a into r minus 1. Great. So here our a is 2 by 3, and you can just see that we are multiplying it with 1 by 3. So our second term would be 2 by 2 upon 9, 2 by 27, 2 by 81, and goes on. Now here's a catch. If this is up to infinity, like here, what we will do is use a formula for infinite GP. Sum would be first term, which is a, upon 1 minus r, but there is a condition that r must be less than 1 mod of r. Fortunately here r is less than 1, so we can say that our sum would be 2 by 3 upon r, which is 1 by 3. You can see 2 by 3 into 1 by 3, our second term is 2 by 9, then 2 by 9 into 1 by 3 is 2 by 27. So it goes on and on. So minus 1 by 3. I'm tired of this. Can't I just move it? So minus 1 by 3. So this will be 2 by 3 upon 2 by 3, which will be 1. So we can confidently say that this is a valid PMF. So coming back to the question, we have to find the CDF. So what we will do is, wait a minute. This is good. So we can see that k has the initial value 1. So we can again confidently say that for x less than 1, p of, sorry, here f of x we can say. So f of x, which will be equal to p of x less than 1, will be 0. So for here we can see of a range 1 to 2, where it's close bracket for 1, we can see that in this range x can only take the value 1. So we will put k equals to 1, and we will get f of x equals to p of 1, which will be equal to 2 by 3 for the range of 2 to 3 we x equals to, so we will write it like this. Here we will write it p of x1 plus p of x2 because it will include both of them. I hope you are understanding my point. So here uh, it will be 2 by 3 plus 2 by 9, which will be something like 8 by 9. Yeah. So here we can see that for x belonging to the range k to x for k plus 1, where k is greater than 0, of course, you can even say that k is greater than equal to 1. It is true. So for this, we will write it like f of x will be equal to p of x1 plus p of x2 plus p of 3 up to p of, I hope you are clear with this point. It is pretty logical seeing from this one. Okay, so what we can do is we can observe that it is just this GP that we were just solving above. So 2 by 9 plus 2 by 27 up to 2 by k, 2 by 2 by 3 raised to power k. So now here we will be using actual formula for GP. So the actual formula for GP is for a GP like this, where it is, yeah. So for a GP like 2 by 3, 2 by 9, 2 by 27 up to 2 by 3k, we will write the last term like 2 by 3 into 1 by 3k minus 1 to get a better understanding of the last term, and our first term is 2 by 3 obviously. So here the geometric progression, sum of geometric progression is equal to a into 1 minus r raised to power n plus 1, where we are finding for n terms. So here I will like write Sn upon 1 minus r. When we use the limit, this terms tends to 0, so we just get the, sorry, this term tends to 1 because it is approximately 0 and 1 minus 0 is 1, so we get a upon 1 minus r. This is the actual like sum. So here Sn, yeah, I would say Sk would be, sorry, Sk minus 1 would be 2 by 3 into 1 minus uh, 1 by 3 raised to power k. You can see that it is actually k minus 1. When you add plus 1, it's just get 1 by 3 raised to power k upon 1 minus 3. So you can see that it cancels out. So our answer would be uh, 1 minus 1 by 3k, 3 raised to power k, which will be 3 raised to power k minus 1 upon 3k. So in this situation, here we can write it sorry Wait a minute. This will be 3 raised to power k minus 1 upon 3 raised to power k. So CDF would be in form of this. For any value, we can just get the CDF. So now, here comes our question. We have to find, for this question, let me just clear this up. So, our question is, we have to find probability of getting x from the range 2 to 4. So, let's just make it equal to. That's good. So, what we will do is use the formula P of x 4. Like if you are given for any PMF, you have to find from A to B. It doesn't matter if it is actually enclosed with it or not. It doesn't matter. What you just need to do is use the formula f of x b minus f of x a. Remember, it's for PMF, not PDF. So for PDF, you need to actually find the area. So I'll discuss it in latest lecture. Yeah. So here, uh, P of x 2. So P of 4 2, and using the formula which we derived before, we will use 3 raised to power 4 minus 1 upon 3 raised to power 4 minus 3 raised to power 2 minus 1 upon 3 raised to power 2. This is 81 minus 1, 80 by 81 minus 8 by 9. So we get 8 by 81. Actually, it is 80 minus 72. So 8 by 81. Next, yeah, one can also ask you a question. P of x greater than 5. You can pause the video and solve it yourself. So to solve this question, we will do is use, like, there's a suppose there's a range like 1 2 3 4 5 6 and so on, है ना? You are asked to find the probability of this, and you know that a probability of whole sums up to 1. So what will you do? You will subtract this term, this one, from 1, and you will get this. Okay, so we can say this like probability of a random variable greater than 5 will be equal to 1 minus probability of a random variable being less than or equal to 5. I hope you understand. So in this question we can use it. One minus P of 5 we can calculate again from this one. 3 raised to power k is 5, so 3 raised to power 5 minus 1 upon 3 raised to power 5. 1 minus 242 by 243. Our answer will be 1 by 243. So this is the answer. Uh, Now I'll be proceeding to expectation. This is all for the application of discrete random variable and the PMF. Now the expectation. So the expectation is, we can just see it by definition, that it is kind of mean of a discrete random variable with respect to their probability. So let there be a discrete random variable x which takes the value like xi. It can xi would be a range from positive or any range. It's not defined for now. So and along its PMF. So probability of xi for any real value function g, we can say that the expected value of g of x will be g of x would be, this is pretty this is relative to the function.